Welcome to Samadhan Life Science. Today I will continue from my last video which was about thermodynamics. So last day I was talking about state function and path functions. I will continue from that and start with entropy, which is the measure of disorderness or randomness in a system, and we can express change in entropy delta S as change in heat in a reversible process divided by T, temperature. So let's remember that this only applies when the heat change has happened in a reversible process. This entropy is a state function. So this only depends on the initial and final state, not on the path the process has taken to reach the final stage. Now, if in a process the disorderness is increasing, then the change in entropy is greater than 0 and the process is favorable. But if in a process the disorderness is decreasing, that means the system is becoming more ordered, then change in entropy is less than 0 and the process is unfavorable. To the next topic, Gibbs free energy. The G is maximum amount of energy an object can have to do some work, and this depends on two functions, enthalpy and entropy. So we can express change in free energy delta G is equal to change in enthalpy delta H minus T delta S. T here is temperature in Kelvin. Now for a particular reaction we can predict the spontaneity according to the sign or the free energy. So if the delta G is negative less than 0, then the process is spontaneous, and if delta G is greater than 0, then the process is non-spontaneous. So for example, if we have a reaction where from a reactant R to product P is forming and delta G is negative, then this reaction is spontaneous. But if delta G is positive for this reaction, then this reaction is not spontaneous. But the opposite reaction, that means P to R, can be spontaneous on that particular conditions like temperature or pressure. Okay. Now for if the delta G has a value of 0, then the process or the reaction is in equilibrium. Now depending on the H sign on enthalpy and entropy, the sign on delta G changes. For example, if the enthalpy change is negative and entropy change is positive, then delta G is negative, always negative, and the process is spontaneous. Similarly, if the sign changes, then the sign on delta G can change also. Now to the next topic, work. In the last video, I discussed about work, and to continue, work is applied force into displacement due to that applied force. Now this work can happen in two different processes. First is reversible process. When the process is reversible, when the process happens in infinitesimal number of small steps, and in every step the system is in equilibrium with the surrounding, and we can reverse every step, then the process is reversible. And for the work happening in a reversible process, we can express as minus V1 to V2 P dV. And if this process is for ideal gas, then we can simplify this equation as W reversible, work happening in reversible process, is equal to minus nRT ln V2 by V1. So for example, 1 mole of ideal gas expands isothermally and reversibly from 1 liter to 5 liter at this particular temperature. So W reversible is equal to minus nRT ln V2 by V1. So N1 into R 8.314 into temperature 300 into ln 5 by 1, and this will come around 4000 joule. And for the irreversible process, the process is faster than the reversible process, and it happens with a finite driving force. So for irreversible process, work done is equal to minus P external into V2 minus V1. So for the similar process, similar gas expansion from 1 liter to 5 liter, but against a constant external pressure of 1 atmosphere, work done irreversibly will be equal to minus 1, 5 minus 1, final minus initial, equal to 4 minus 4 liter atmosphere, and this will be equal to around 405 joule. So see, the work done in reversible and irreversible process for the same initial and final step are different. So let's move on to the previous year question. So first question, among the following processes which is reversible under the given condition? For this question our answer is A, melting of ice at 0 degree centigrade. Why? Because at 0 degree centigrade both solid and liquid, that means here ice and water, can coexist, and the process is in slow and happens in infinitesimal stage, infinitesimal small steps, and in any step for an infinitesimal change of temperature and pressure can reverse the process. That means melting and freezing, they can reverse. So this is closest to an reversible process. So but this option B also looks similar, but this is not a reversible process. Why? Because evaporation starts below 100 degrees centigrade, and the loosely bounded water in the surface start evaporating and going to the atmosphere below 100 degrees centigrade, where the surrounding is, that means the atmosphere is not at the same temperature or vapor pressure for the system. So this is not a reversible process. And for option C, expansion of gas in vacuum, the gas is expanding freely without any external pressure. That means that is also a reversible process. And for the last option D, heat flow from a hot to cold body, there is a definite temperature difference which act as a finite driving force. So this is also an irreversible process. So finally the answer is A, melting of ice at 0 degree centigrade is a reversible process. The last question for today, which of the following statement regarding reversible and irreversible gas expansion is correct? The answer is B. Work done in reversible expansion is greater than in irreversible expansion. So, for example, in this problem also we saw that the work done in reversible process is larger than the work done in irreversible process, where the initial and the final states were similar, right? So this is true all the time. So we can write that work done in reversible process is greater than work done in irreversible process always, and this I use to get rid of the positive or negative sign for the value. We only consider the value. So this is also always true that the work done in reversible is always the maximum work done we can get. So I hope this clear the concept for reversible and irreversible work for you, and you understand the concept of spontaneity. I hope you enjoyed the video. Thank you for watching. See you in the next video. Bye bye.